Hello, Algebra 1. In Lesson 3 here, we're going to start working with positive and negative numbers, and we're going to use red and black checkers to help us see this happen. Here we go. The first thing you need to know in this lesson is right here. Our black checkers are going to represent positive 1, and our red checkers are going to represent negative 1. So in this example, we have 2 black checkers and 5 red checkers. The total score would be -3, because when you combine positive 1 and negative 1, that's just 0. Again, here, positive 1, negative 1, that's just 0. So you're left with -3. So starting with number 1, we have 4 red checkers. Each one of those is -1. And so the total score here would be -4. In number 2, our total score would be +7 because there's 7 black checkers. In number 3, now we have pairs of positive and -1. So those are our 0 pairs. So we'll get rid of those. And what we're left with is a +1, so our total score in number 3 is 1. In number 4, we have a 0 pair right there. What we're left with is 6 -1s, or a total of -6. Number 5, if the score is negative, are there more black or red checkers in the pile? In order for it to be negative, there needs to be more red checkers, because that's what's going to make your number negative. Number 6, if the score is positive, which color is ahead or has more checkers? If you have a positive number, that means you have more black checkers, or your positive 1s. In number 7, if the number of black and red checkers is the same, what is the score? And that would be 0. If you're not sure, you can always draw out an example. When you're drawing, you can just use a plus sign for a black checker and a negative sign for a red checker. And we'll just draw a few of them here. If I have the same number of black checkers, same number of red checkers, these all end up being 0 pairs, and so we get 0. Number 8, now we're going to start writing these with an equation. And so if black is ahead by 5, there's our +5. Find the new score if you put in 3 red checkers. 3 red checkers would be -3, and so we end up with 5 plus -3, which would be 2. And again, you can always draw this out. Here's my 5 black checkers. Here's my 3 red checkers, and I end up with some 0 pairs, and I'm left with +2 right there. In number 9, red was ahead by 5, so there's my 5 red checkers. Put in 3 black checkers, there they are right there, and what I'm left with is some 0 pairs, and then we're left with 2 red ones, so that would be -2. In number 10, black is ahead by 1, so you have a +1, and then you put in, or you add, 4 red checkers, which are all negatives, and you would end up with -3. You have a 0 pair right there, and you end up with your -3. In number 11, this is unique because we start out with 6 red checkers, and then we put in 6 more red checkers. There's no 0 pairs here, so our equation is -6 plus -6 equals -12. In number 12, we do have some 0 pairs, right here and right here, and so we end up with -2 that we started with, plus 4 black ones equals +2. In number 13, again, we're starting with negatives, 3 red ones, and we put in or add 4 more red ones, so -3 plus -4 equals -7. Number 14 and 15 are referring to these checkers right here. Red is currently ahead by 1. I redrew the checkers right here. There's 5 red ones and 4 black ones. So after our 0 pairs, we would look like this. So red is ahead by 1. If we put in 3 red checkers, or add in 3 red checkers, what are we at now? So we were at -1, we added in 3 red ones, and now we're at -4. In number 15, I redrew the checkers right here again. Again, red is ahead by 1. I'm not going to cross out my 0 pairs here because we're going to take out 3 black checkers. So I'm just going to cross out 3 black checkers. And now what are we left with? Well, we still have 1 0 pair left, and you can see that we are left with -4. As an equation, this would be the -1 that we started out with. Red was ahead by -1. We took out, or we subtracted, 3 black checkers, and we end up with -4. Number 16 is really looking back at 14 and 15 and noticing that these are the same. So adding a negative is the same thing as subtracting a positive number. So keep in mind that these two operations end up being the exact same. In number 17, if black is ahead by 5 and we remove, that subtract, 2 black checkers, we're left with 3 black checkers. For number 18, I want you to draw this picture with me. Black is ahead by 5 and we're going to remove 2 red checkers. So I needed a picture where I had 2 red checkers to remove and black was still ahead by 5. If you notice, I have a 0 pair here and here, and so black is currently ahead by 5. So here's my ahead by 5. Now I'm going to remove or take out 2 red checkers. So I'm going to remove my 2 red checkers. And what am I left with? I'm left with 7 black checkers. So what we're trying to see here is that removing those negatives ends up being the same operation as adding 5 plus 2. 19 is similar in that I'm going to start with a problem where red is ahead by 6 and I'm going to remove 1 black checker. So I needed a picture where I have a black checker to remove and I'm still ahead, red is still ahead by 6. And so we can see that this is a 0 pair right here. So red is currently ahead by 6. So I start out with negative 6 as what we start out with. And we're going to remove 1 black checker. So minus 1. So I'm going to take out this black checker. So now I can see what I'm left with is negative 7. So as you do these problems, draw things out, cross things out, do what you need to make sense of it. You can also use number lines if you're starting to see the connection between this and number lines. In number 20, red was ahead by 3, but I still needed a picture where I could remove 6 black checkers. So I started out with this picture, and I knew that I started out with red ahead by negative 3. I took away, or I removed 6 black checkers, and so I'm left with negative 9. So your equation would be negative 3 minus 6 equals negative 9. 21, I started out with negative 7, or 7 red checkers, and I took 3 of those away. So minus negative 3. This is me taking away 3 red checkers. And you can see from the picture that we're left with negative 4. And so again, this is getting back to the idea that subtracting a negative is the same thing mathematically as adding. So negative 7 plus 3 equals negative 4. Make sure you have this written both ways right there. Number 22, we have red or black being ahead by 1, but I still needed a picture where I could remove 5 black checkers. So I started out with this picture where black was originally ahead by 1, but I still had black checkers I could remove. So by taking out those 5 black checkers, now I have a 0 pair right here I can get rid of, and what I'm left with is negative 4. So mathematically my equation is 1 minus 5 took away 5 black checkers, and that was equal to negative 4. Here we're starting to introduce you to who am I puzzles, and this really gets you thinking about numbers in different ways and kind of in the way of solving puzzles about them. So first one tells you that I am even, and so in the units digit or the ones digit, we know that has to be 0, 2, 4, 6, or 8. And the sum of my digits is 16. Now this can only be a 2-digit number, and so it can be some trial and error, but as you figure this out, we would end up with 88 being the number where the sum of the digits when you add them together is 16 and it's even. As you work on these, definitely do some trial and error as you go. Let's look at number 29. The sum of my digits is 4. So right now I'm thinking like 2 plus 2, right? But my units digit is not 2, so it can't be that. I am an even 2-digit number. So that means my units digit has to be 0, because anything greater than that in that units digit would get me a sum greater than 4. And so that means my tens digit has to be 4. So the number 40 meets all of these requirements.